Hey Algebra 1, welcome to another video on Algebra 1 material. So today we're going to be talking about, is it a function? So we're going to talk about function and whether or not a relationship is a function. We're going to start off by adding to our table of contents. So right now what you need to do is you need to pause this video, open to page 2 of your Outstanding Math Guide, your OMG, and you need to make sure your table of contents looks just like this right over here. Make it look like that. Pause the video. Now that you've updated your table of contents, let's go ahead and start. So today, our goal is I can determine if a relation is a function. So today we want to make sure and be able to determine whether or not a relation is a function. So, is it a function? We're going to use something called the vertical line test. The vertical line test is a way to check and tell if a relation is a function. So, we know we're going to pass the vertical line test as long as our vertical line never, ever, ever touches our graph more than one time. It can touch one time, no more than once. If our relation passes the test, then we're allowed to say that relation is a function. Not all relations are functions, only the special ones. So there are 4 ways a relation can be represented. The first one is a graph. So the first way is a graph. So we've all seen a graph. So a graph is our XY coordinate plane, and we would have a graph. Okay? So the first relation can be represented as a graph. It can also be represented as an equation. So a function or relation can be represented as an equation. So f of x equals 2x plus 1. Okay? Equation. We may also see a problem that's either a tabled, ordered pairs, or a mapping. So a table, we may have an XY table with our numbers. It may be ordered pairs. It might be a list of ordered pairs. 2, 3, 4, 6, 5, 5. It also might be a mapping. So I don't know if we've ever seen a mapping before, but here's what it looks like. You may have 2 bubbles filled with numbers and arrows that represent our x values going to y values. Okay, where our first bubble represents our x values and our second bubble in our mapping represents our y value. The last way we may see a problem is it could be a story problem. Okay? It could be a story problem, so written out in words. John went to the store. He paid a membership fee of $5. And every time he goes, he has to pay $2. Okay? It may be a story problem. So you may see either graph, equations, tables, ordered pairs, mappings, or story problems. So there's lots of different ways to determine and see relations and see if they're functions. So graphs, we're going to use the vertical line test. Okay? Equations, we're going to type them into Desmos and use Desmos to determine after using the vertical line test. Ordered pairs, tables, and mappings will also use the vertical line test as well as Desmos to help us out. Finally, story problems. We're going to first have to make a table, enter it in Desmos, and use the vertical line test. Okay, we're going to have a bunch of practice. So before I move on to the next slide, okay, make sure you know how to go to Desmos, desmos.com/testing/Ohio/graphing. Okay? We're going to be using a lot of Desmos to determine functions. Okay? So, before I go over each problem, I want you to make sure you pause the video and copy down a beautiful example. So each example you need to copy down, and it needs to be beautiful. So pause the video and take your time with each of those. So our very first problem, I'm going to look at this and I'm going to think, this is a graph. When I see a graph, I am going to use the vertical line test. The vertical line test is when we take a vertical line. You may want to use your pen or your pencil. You're going to lay it down on your problem, and you're going to slowly slide it across. And you're going to see if it ever hits the graph more than once. So I drew myself a nice straight vertical line, and I'm going to start on the left side of my graph. As I move it over, I'm trying to make sure my vertical line never touches my graph twice. So for example, right here at -3, I only hit the graph one time. So I'm going to keep going and keep checking my graph. Still one time, still one time, still one time. Ooh, this is weird. We have these two odd looking points. So one of them is filled in, but one of them is open, and we call that a hole. So when my line is right on top of that spot where there's a point and a hole, it looks like we're going to hit the graph twice, but really we're only hitting it once. My line's going to hit the solid point and go right through the open point. So even though it looks like I'm hitting it twice, I'm only looking at hitting it once. So I'm going to keep checking my graph, keep moving my line, and it looks like my vertical line is never going to hit my graph more than one time. It's never going to hit the graph more than one time. Okay, so we know for sure that this is a function. And this is a function because it passes the vertical line test. Okay, what would have happened if this was filled in? So let's say that hole was filled in. Well, now if I put my vertical line there, it would hit twice. So because that's a hole, my vertical line goes right through it, and it does not count as hitting twice. So this is a function. Okay, next example. Remember, pause the video and make sure you copy it down. Okay, so you've copied down the problem. This is what we call a mapping. So this is a mapping where the first big bubble is our x values, and our second big bubble are all of our y values. So even though this looks nuts, it looks crazy, all this is a bunch of coordinate points. So let's start by making a table and putting these coordinates in it. So I'm going to draw a nice big table. I have my x values on one side, my y values on the other. So if I look, I have a -8 going to a 7. So I'm going to write -8 for my x value, and I'm going to write 7 for my y value because I have an arrow going from -8 to 7. Okay, now I'm going to look at my -1. That's an x value, and I can see my -1 is going to the 9. So I know I have the point -1, 9. Okay, I have no more arrows, so let's go to the next one. I have 0 as an x value, and my 0 is going to 9. Okay, my 0 is going to 9. 0 only has one arrow. So I know that I don't have to write 0 any more times. Now 15 is special. See how 15, my x value, has 2 arrows. That means I'm going to write 15 twice in my table. I can see that 15 goes to 7 and 15 goes to 9. So I need to write those. 15 goes to 7 and 15 goes to 9. Okay, so I made my table. Now, how am I going to do the vertical line test? Well, I'm going to go over to Desmos, which I have open right next to it, and I need to put this table into Desmos. So how do I do that? Okay, I'm going to click this gear right here. I'm going to click, sorry, not the gear, the plus, and that means I'm going to add a table. So I'm going to add a table, and I'm going to type in my table into Desmos. -8, -1, 0. Don't forget we had two 15s. Y values, I had 7, 9, 9, 7, 9. So now over here on my right is my graph. So here's a trick though. Sometimes I only see 3 points, which means I probably need to zoom out just a little bit. So here is my graph, and here are all of my points. Okay? So we need to imagine we're doing the vertical line test. And what I'm going to do is I'm going to actually make a vertical line. So you don't have to do this, but here's my vertical line. And I'm going to start, and I'm going to slowly move my line over. Okay? I'm going to slowly move my line over. So starting at -10, the first point I hit is here, but I'm only hitting 1 point, so that's okay. I keep moving. Oop, hit another point, but it's okay. We're only hitting 1 point. And I'm going to keep checking, and then all of a sudden right here, my vertical line hits 2 points, which is a no-no, which means my relation is not a function. So I'm going to go to my problem, and I'm going to write not a function. It is not a function. And we know this is not a function because my blue vertical line is hitting 2 points at the same time. So this is not a function. All right. Remember, next, I'm going to go to the next slide, pause the video, and copy down the problem. Here we have a story problem, another way we could see a relation. So we know that the corner alley charges $4 per game and $3 for bowling shoe rentals. We need to graph the relationship between the number of games and total cost. We need to determine, is this story problem a relation or is it a function? Okay? So we don't have any points to put in a table yet. So what we need to do is we need to create a table. So I'm going to start by drawing a nice table. Okay? A nice table. Okay? So we are going to have my X and Y values, but we need to figure out what does X represent and what does Y represent. So if I read this, the corner alley charges $4 per game and $3 for bowling shoe rentals. So my X values are going to be whatever's going to be changing. So a good giveaway is this word per. Okay, per game. So the number of games that we play is going to change. Okay, we might play 1 game, we might play 2 games, we might play 3, 4, 5. We could play any number of games. Whereas our 3 is how much it costs for bowling shoe rentals. Bowling shoe rentals. So that's something that we're only going to do one time. So let's think. How much would a game cost if I were just playing 1 game? So if I was playing 1 game of bowling, it would cost me $4 for 1 game plus $3 to rent my shoe. So my total cost would be $7. So we know X is going to represent the number of games. We played 1 game. And we know that 7 is going to be the total cost. Total cost. Okay? Or we could just say cost. So 1 game is $7. 2 games would be $4 for the first game, $4 for the second game, and $3 for the bowling shoe rental. Which means this is going to cost for $11. Okay, $11. Let's do another one. Okay, I'm going to play 3 games of bowling. So I would have $4 for the first game, $4 for the second game, $4 for the third game, and I have to rent my bowling shoes for $3. So I have $4, $8, $12, $15. $15. Now we could keep going all day, but what do you notice? How much is this going up by each time? 7 to 11 is 4. 11 to 15 is 4. So if you had to guess, what would be our next cost for 4 games? Well, if we're going up by 4, it's going to be $19. And we could keep going and going and going, but I think we have enough. So I'm going to go over to my Desmos. I'm going to add a table. My X values were 1, 2, 3, 4. My Y values, my cost was 7, 11, 15, and 19. So I'm going to make sure I can see all my points. I'm going to take my pencil, put it up on the graph, and I'm going to check, okay, I only hit 1 point there. I'm only hitting 1 point, 1 point, 1 point. So I'm never hitting more than 1 point at a time. So this passes the vertical line test. So I know that this is a function. This is a function. So story problems, you're going to need to make a table, put it into Desmos, put your pencil on the paper, and check and see, or on your computer and check and see, does my pencil, my vertical line, ever hit 2 points at the same time? And in this case, it didn't. It's a function. Okay, pause your video, write down the problem. So this is an equation. We actually have a function written out as an equation. And you may be like, whoa, Mr. Tokar, Miss Castor, Miss McDonald, what is this nonsense? This is called function notation. So it's another way to write an equation. So if we have a problem in function notation, this is the easiest one. The first step is plug it into Desmos. Plug it into Desmos. So I'm going to go over to Desmos, and I'm going to plug in my function exactly how it looks. F parentheses, x parentheses, or f of x equals negative 1/2 x plus 15. Okay? Something you may have to do, if you are looking at nothing, you may have to zoom out to see your line or your function. Okay? Next, easy. Number 2, we will do the vertical line test. So again, you're going to put your pen or pencil on your computer screen. You're going to start on the left and move it all the way to the right. I have a little fancy line. If I slide this across my graph, you can notice no matter where I put it, my vertical line only hits my graph one time. One time. It never hits twice. Okay, so this is a function because it passes the vertical line test. Function. Function. Step 1, plug it into Desmos. Step 2, do the vertical line test. Okay, here we go. Copy this down. Copy this down. Okay, so now we are given a table, and we have to determine how I'm going to make this into not a function. So I have a table that's not fully filled out. It's got some missing spots. It's my job to make this not a function. So make sure we're reading the problem. Look, not a function. I want this to not be a function. So I'm going to start by going to Desmos, and I'm going to add in a table. And I'm going to copy in what they've given us so far. So here's my table with all of my blanks. Okay? There's my table with all my blanks. Now I have to figure out how can I put numbers in here so that my vertical line hits that point 2 times or more. So let's start by picking some random y values. How does 2 sound? Let's get a 4 in there, and let's do a 5 at the end. Okay? So right now it's still a function. If you look, I have 2 points. My graph is not hitting those at all. So how am I going to make this table not a function? Well, if you can see, I have 2 of the same y values, and that doesn't seem to be a problem. However, if we ever want to make a table not a function, it all has to do with the x values. So we made this 2, we made this 4, and we made this 5, and it looks like it's still a function. The key to this problem lies with my x column. So in order to make this not a function, we want to have 2 x values that are exactly the same. So there's a couple ways I could do this. I have a 3 and a 5. If I want to immediately make this not a function, I just need to have 2 of the same x values. So let's say I put 3 in under the x. Look what happens. If I look at my graph, my vertical line now hits that point twice. It's already not a function. I've done it, and it doesn't even matter what this last one is. Well, let's say we really want it to not be a function. I'll put another 3 in the x column. Now look, my vertical line hits 3 times. So we failed the vertical line test. What are some other numbers we could have put in here? Pause the video, think about it. What are some other numbers we could put in here to make it not a function? Pause the video, think about it. So we could have also put 5. If I go to my table and change it to 5s, now look. If I go over here and move my slider, I'm hitting a bunch of points. And 2 of my points are exactly the same. Okay, I could have done 1, 5, and 1, 3. 1, 5, and 1, 3. And look, now there's another spot I hit twice. So the key to making a table not a function is you want an x value to repeat. You want to have 2 of the same x values. Y value doesn't matter. You can have all the same y values and it's fine. Okay, I could have had 4, 4, 4. Let's make this 1 and 2. Let's see what happens. 3, 1, 5, 2, 4, 4, 4, 4. And look, even though we have a bunch of the same y values, it's fine. It's still a function. It never hits twice. Never allowed more than 1 of the x values. You can't have 2 3s or 2 2s or 4 4s or 6 7s. Y values you can, x values you cannot. Okay, so make sure you got all of these notes down. Copy them into your notebook, your OMG. Have a great day. Algebra 1 out.